at noon, ship A is 150 kilometers west. Okay, so that's the location of ship A from B. So ship A is sailing east 35 kilometers per hour, and ship B is sailing 25 kilometers north at 25 kilometers per hour. How fast is the distance between those ships? I made a typo there. Ship changing at 4 p.m. Okay, so I don't know if you can see this. What's happening here is this: as this event unfolds, right? So let's say B moved up a bit because it's going north. Do you see that there's a right-angle triangle relationship here? Now, A will move to the right. Okay, so as A moves to the right, B goes up. So a little bit time later, we'll get another different type of right-angle triangle. But the fact remains, we have a right-angle triangle relationship here. Okay, so let me call this here y, and let me call this x. So we're given dx over dt. Okay, that's 35 kilometers per hour, but my x is referring to distance. And since it's decreasing that distance, we have to say this is minus 35 kilometers per hour. The 25 kilometers per hour is referring to how the y is increasing. So let's say dy over dt is then the positive 25 kilometers per hour. Okay, so let me call the length of the hypotenuse s. And there's this relationship where x squared plus y squared is equal to s squared by Pythagorean theorem. Okay, so we're starting at noon, and we want to know how fast the distance between the two ships are changing at 4 p.m. So that means after 4 hours has passed by. Okay, so let's differentiate this equation here in respect to time. We get 2x dx over dt, right? 2y dy over dt, 2s ds over dt. Okay, so we can divide both sides by 2 to get rid of this 2 here. Okay, so let's fill in what we have. We know dx over dt is minus 35. So we know dy over dt is a positive 25. Okay, after 4 hours has passed by, x will be 150. Okay, so 150 minus 4 times 35. And y will be 25 times by, so 25 kilometers per hour. So times that by 4, and you get the distance that you traveled. Okay, and so let's actually figure out what this is. Okay, so that's 150 minus 140. Right. So you get exactly 10 here. 10 times minus 35. Subtract that, you get 10. And here we have 100. So we have a triangle that looks like this, a 10, 100. So the length of S will be 100 squared plus 10 squared. You can factor out a 10, and you get 10 squared plus 1. So it's 101. 10 times root of 101. Okay, so let me replace here. We have a 100 times by 25. S, and we replace that with 10 times root of 101 ds over dt. Okay, so you get that if you clean up the left side. Let's divide both sides by this. Okay, so we get 2125 over 10 root 101 is the rate at which the distance between A and B is changing. And we get approximately 21.4. So ds over dt is 21.4. Okay, this is in kilometers per hour. Okay, so that's how fast the distance between those two are growing. Okay, so note that because I got a positive value here, this positive number means the distance between the two ships are growing. If I got a negative number here, it means actually the distance between the two ships is shrinking.